This is the Honors Geometry exam review for Unit 3. Don't forget that on the exam you will be given a formula sheet, and for the Unit 3 topics this is going to be really helpful because it has area and circumference of figures, volume, and the density formula. So these are the ones that you do not need to memorize, but make sure you understand how to use them. And you're given 2 sheets of formulas, so do be sure to go through them. So Unit 3, Question 1. Which pairs of figures have the same volume? Looking at Part A, we see that we've got 2 different cones, and the volume of a cone is 1/3 area of the base, which is a capital B, times height. So volume is 1/3 the area of the base, which is a circle, so pi r squared times height. Well, they both have a radius of 4 and they both have a height of 6, so these cones are going to have the same volume. For B, we have the bases are square, so we have a square pyramid. And the volume of a pyramid is 1/3 area of the base times the height. So because it's square, it's going to be 1/3 area of the base, which is, base times height, lowercase b in this case, and then height of the figure. Well, they're both going to have the same area of the base because they're both squares with a side length of 5. They both have the same height of 6. So both of these pyramids are going to have the same volume. Finally, we have C. And what we know is the cross sections equidistant from the bases are congruent and the heights of the solids are equal. So this is basically going to be using Cavallari's principle . And Cavallari's principle says that given 2 solids that are included between 2 parallel planes, these being our parallel planes, if every plane parallel to the 2 planes intersects both solids in cross-sections of equal area, which is what it says here, then the volumes of the 2 solids are equal. So this one is also going to have the same volume. For items 2 through 4, we're going to find the volume if each figure is revolved around the dashed line. So the first thing you have to do is kind of figure out what it means to revolve it around the dashed line, what kind of figure you're going to get. So if we take this triangle in question number 2 and revolve it around the vertical line, what we're going to end up getting is a cone. That cone is going to have a height of 3 units, and it's going to have a radius of 5 units. So to find volume, it's going to be 1/3 the area of the base times the height. So this is going to be 1/3 area of the base is pi r squared times the height. So volume equals 1/3 pi times 5 squared times 3. Well, 5 squared is 25, and 3 times 1/3 is going to be 1. So this volume is going to be 25 pi, which rounds to about 78.540. 3, we're rotating it around a horizontal line, which is going to end up giving us a cylinder that's on its side. Well, the radius of the cylinder is going to be 4, and the height of this cylinder is going to be 7. So we're going to do volume equals the area of the base times the height. The area of my base is pi r squared times my height. So my volume is going to be pi times my radius, which is 4 squared, times 7. This is going to give me 16 pi times 7, which is 112 pi, and that is approximately 351.858. finally, for this last one, we have this dashed line, but our figure is 2 units away from the dashed line. We know that a rectangle will give us a cylinder, but it's going to have a hole in the middle. So we're going to have a cylinder within a cylinder. That is a terrible picture of this. Sorry. It's going to be a... Let's try again. It's going to be a cylinder, a big cylinder, with a hole in the middle. It's a little bit better. So basically, the best way to find the volume is to take the volume of the big cylinder and subtract by the volume of the small cylinder. Well, the radius of the small cylinder is going to be this 2 right here. So my radius is going to be 2, and the radius of my big cylinder is going to be this 2 plus this 3 to give me a radius of 5. Both of them are going to have a height of 6. So my volume is going to be volume of a cylinder, which is pi r squared h minus pi r squared h. And so we're going to have pi times my radius, which is 5, squared times my height of 6, minus pi times my radius of 2 squared times 6. Volume equals, this is going to be 25 pi times 6, 25 pi times 6, minus 4 pi times 6. So 25 pi times 6 is 150 pi minus 24 pi. So my volume is going to be 126 pi, or approximately 395.841 units cubed. For question 5, we're asked to name the cross-section that is formed in each case. So we're going to start with a cone. So we've got a cone cut by a plane parallel to the base. So we're cutting parallel to the base, but not through the top. So parallel to the base is going to be a circle, because it's basically the shape of the base. Now, a cone cut by a plane perpendicular to the base through the apex. So let's think if I took a square piece and cut it straight through, what I'd end up getting is the shape made by the intersection, which is going to be a triangle. Next, we have a rectangular pyramid, and it's cut by a plane parallel to the base, not through the apex. So if it's cut parallel to the base, it's going to be the shape of the base, which is going to be a rectangle. Then we have a square pyramid cut by a plane perpendicular to the base, not through the apex. And it's through one side only. So if I cut through this, and I'm not going through the apex, what I can see is that I'm making a shape that looks like this. So what we're going to have is a trapezoid. All right, if we have a cylinder and it's cut by a plane parallel to the base, it's going to be the shape of the base, which is a circle. And if I have a cylinder cut by a plane perpendicular to the base, that's again like me taking a shape, slicing it through. I'm going to be left with a rectangle. Question 6 says, what is the relationship between the volumes of a cone and a cylinder if the cone and cylinder have the same radii and heights? Well, the volume of a cone is 1/3 the area of the base times the height. The volume for a cylinder is the area of the base times the height. Well, the area of the base for a cone and a cylinder is going to be pi r squared. And since we know that they both have the same radii and the heights, and the same height, we know that the area of the base times the height is going to be the same. So basically, for a cone compared to a cylinder, we're talking about 1/3 area of the base to the area of the base, which is really a difference of 1/3 of the other. So the volume of a cone is 1/3 the volume of the cylinder. Question 7 says, what is the relationship between the volumes of a pyramid and a prism if the pyramid and prism have the same base areas and heights? So our pyramid has a volume of 1/3 area of the base times height, and a prism has a volume of the area of the base times the height. Well, since they have the same base areas and the same heights, again, we see the same relationship as number 6. The volume of the pyramid is 1/3 the volume of the prism. Number 8, a scoop of ice cream is in the shape of a sphere with radius 3 centimeters, and it's placed in a cone that has a radius of 2 centimeters and a height of 9 centimeters. If the ice cream melts into the cone, will the ice cream overflow the cone? Show how you determined your answer. Well, basically what we need to do is we need to find the volume of the sphere. Spelled that wrong, sorry. We need to find the volume of the sphere and the cone. The sphere is going to have a radius of 3 centimeters, and the volume of a sphere is 4/3 pi r cubed. So my volume is going to be 4/3 pi times 3 centimeters cubed. So the volume is 4/3 pi, 3 cubed is 27, so it's 27 centimeters cubed. Well, 27 times 4/3 is basically 27 divided by 3, which is 9, times 4, so we have 36 pi centimeters cubed. And this is going to come out to approximately 113.097 centimeters cubed. Now I need to find the volume of the cone. And the cone's got a radius of 2 centimeters and a height of 9 centimeters. Well, the volume of a cone is 1/3 times the area of the base times the height. And since it's a cone, the area of the base is going to be pi r squared times the height. So my volume is going to be 1/3 pi times 2 centimeters squared times a height of 9 centimeters. I'm going to multiply my 1/3 times my 9 centimeters to get 3 centimeters times pi times 2 centimeters squared, which is 4 centimeters squared. 4 times 3 is 12, so we're going to have 12 pi centimeters cubed, and this is going to be approximately 37.699 centimeters cubed. Since the cone holds 37.699 centimeters cubed worth of, liquid, but our ice cream is going to be 113.09 centimeters cubed of liquid, then we can see that yes, it will overflow. And it will overflow because the cone can't hold all of the volume of the ice cream. Number 9 says the scoop of ice cream in item 8 has a mass of 124 grams. What is the density in grams per centimeter cubed of the ice cream? Well, the formula for density is mass divided by volume. We're told that it's got a mass of 124 grams and it's got a volume of 36 pi centimeters cubed. It is always best to be as accurate as possible, so rather than putting in your rounded answer of 113.097, you should put in 36 pi. So you should take 124 and divide it by 36 pi. And if you use your calculator, put the 36 pi in parentheses so you divide by that whole number. And that's going to give you approximately 1.096 grams per centimeters cubed, and that is our density. Question number 10 says a movie theater sells popcorn in pyramid-shaped boxes whose base is a square of side 15 centimeters and a height of 25 centimeters. What is the volume of the popcorn box? Well, we have this pyramid, and it's a square, so each side is 15 centimeters, and the height is going to be 25 centimeters. So the volume of a pyramid is 1/3 area of the base times the height. So this is 1/3 area of the base. It's a square, so it's going to be side squared times the height, which is 1/3 side, which is 15 centimeters squared times a height of 25 centimeters. Well, 1/3 times 15 centimeters squared is 225 centimeters squared times 25 centimeters. And that is going to give us 1,875 centimeters cubed, which is the volume of the popcorn box. Part B says the density of popcorn is 0.03 grams per cubic centimeter. What is the mass of the popcorn in the box? Well, we know that density equals mass divided by volume. Our density is 0.03 grams per cubic centimeter, and that's going to equal mass divided by our volume, which we found in part A to be 1,875 centimeters cubed. So to solve for mass, we're going to multiply that number on both sides, and we're going to have 0.03 grams per centimeter cubed times 1,875 centimeters cubed. So our units are going to cancel out. We're going to multiply those two numbers together, and we're going to get 56.25 grams, which is the mass of the popcorn in the box. Finally, part C says when popcorn is popped, it is stored in a cube that is 45 centimeters on each side. So we have our cube, we have a side that's 45 centimeters, and it says how many boxes of popcorn can be filled from this container. Well, we first of all need to know the volume of the cube. And the volume of the cube is going to be S cubed, the side length cubed. So 45 centimeters cubed is going to be 91,125 centimeters cubed. I want to know how many boxes of popcorn can be filled from this. So I need to take my volume of my popcorn box, and I'm going to take 91,125 centimeters cubed and divide it by 1,875 centimeters cubed, because that's how much one box holds. These cancel out, and it divides into 48.6. So we know that 48.6 boxes of popcorn can be filled. Really, 48 full containers can be filled, but 48.6 is an appropriate answer for this problem. Question 11 says the three figures below have the same volume. Find the missing height in each case. Well, the first thing we need to do is find the volume that's not missing the height. And the volume of a prism is length times width times height. So we're going to do 6 times 12 times 3, and that's going to give us 216. So this is the volume we're going to use for part A and for part B. So for part A, it's a cube. Well, we don't know. We actually can't make that assumption because we don't know the height. So the volume is going to be length times width times height because it's a prism. Our volume is going to be 216. Our length is 3, our width is 3, and we don't know our height. So 216 equals 9 times our height. And I'm going to divide both sides by 9, and I'm going to get a height of 24. For part B, we have a rectangular pyramid. So the volume is going to be 1/3 the area of the base times the height. Well, we know 216 is the volume. We've got 1/3. My area of my base is going to be length times width times my height. To get rid of the 1/3, I'm going to multiply both sides by 3. So 216 times 3 is 648. And that's going to be equal to my length times my width, which is 24 times 2 times my height. So 648 is going to be equal to 48 times the height. Divide both sides by 48, and my height is going to equal 13.5. For items 12 through 14, we're going to find the volume of each solid described. So for question 12, we've got a sphere with radius of 6 centimeters. So my volume of a sphere is 4/3 pi r cubed. So we're going to have 4/3 pi times 6 centimeters cubed. This is going to give me 4/3 pi times 6 cubed, which is 216 centimeters cubed. 216 times 4/3 is 288 pi centimeters cubed, which is also approximately 904.779 centimeters cubed. Question 13 says a cone with radius 5 centimeters and a height of 9 centimeters. Well, the volume of a cone is 1/3 the area of the base times the height. My area of my base, it's a circle, so I'm going to have 1/3 pi r squared times the height, which equals 1/3 pi times the radius, which is 5 centimeters, squared, times the height of 9 centimeters. So this is going to give us 1/3 pi times 25 centimeters squared times 9 centimeters. I can cancel out the 9 centimeters and the 1/3 by multiplying those together, and that's going to give me pi times 25 centimeters squared times 3 centimeters. So my volume is going to be equal to 75 pi centimeters cubed, which is approximately 235.619 centimeters cubed. For question 14, we have a square pyramid with a base of side 8 centimeters and height of 3 centimeters. So my volume again is going to be 1/3 area of the base times the height, but my area of my base is going to be my side squared times my height. So this is going to be 1/3 times 8 centimeters squared times my height of 3 centimeters. So this is 1/3 times 64 centimeters squared times 3 centimeters. Well, the 3 centimeters and the 1/3 multiply together to give me 1. So I'm going to have 64 centimeters squared times 1 centimeter, which is going to give me a volume of 64 centimeters cubed. Question 15 says a company is producing a special part for a machine. The part consists of a cylinder of tin, which is the white part, that is inside of another cylinder made of copper, which is the shaded part. The part is shown below. Part A asks us, what is the total volume of the entire part? We can give our answer in terms of pi or to the nearest cubic millimeter. So I'm going to take the volume of the cylinder, which is the volume of the area of the base times the height. The area of the base, it's a circle, so pi r squared times height. So pi times my radius of 6 millimeters squared times my height of 5 millimeters. This is going to be equal to 36 millimeters squared times pi times 5 millimeters, which is going to give me 180 pi millimeters cubed. I can also say that this is 565 millimeters cubed, as I needed to round to the nearest cubic millimeter. Part B says, what is the volume of the tin used in the part? Same thing, you may give your answer in terms of pi or to the nearest cubic millimeter. Well, same formula. Volume is the area of the base times the height, so it's pi r squared times the height. So we're going to have pi, but my radius now is 3 millimeters squared times my height of 4 millimeters. 3 millimeters squared is 9 millimeters squared, and we're going to be multiplying that by 4 millimeters. So this is going to give me 36 pi millimeters cubed, or 113 millimeters cubed, if you decide to round it. Finally, we're asked, what is the volume of copper used in the part? You may give your answer in terms of pi or to the nearest cubic millimeter. Well, the volume of the copper is going to be the volume of the shaded region. So to find the volume of the copper, we need to take the volume of the entire part and subtract it by the volume of the tin. Well, the volume of the entire part is 180 pi millimeters cubed, and the volume of the tin is 36 pi millimeters cubed. And if we subtract these two, we're going to get 144 millimeters cubed. Or we can do 565 millimeters cubed minus 113 millimeters cubed, and that's going to give us a total volume of 452 millimeters cubed. Either answer works, but this is the volume of the copper. And that ends our review for the Honors Geometry exam for Unit 3.